Hello everyone. Today we are going to do a problem in IITJ section paper 2 section 2. Several problems, and each problem will be in a separate video because I want to separate them out because they're concerned with different concepts. This section has 3 questions. And you are going to need to be very careful. So this is the question, this section where you have to check each one of the possibilities, okay? Because there is actually negative marking for getting it wrong. So you have to be extremely confident. This section is testing whether you are confident or not. No? Because only correct answers, whenever you mark any of the answers as include any of the wrong answers, then you get negative mark, period. So you're not supposed to include. So if you like A and B is the correct answer and C and D and the wrong answer, and you answer A and B and C, you are out of luck. You get a negative mark. Okay. If you just include A and B, that's very cool. If you just include A, that's also cool because A is in the correct answer. All right. Okay, so here is question number 5, which is the first problem in this section. It's already is a pretty tricky problem. Okay. So here the light comes in. These are the wavefronts. It doesn't tell you when you look at this that these dashed are the wavefronts. Okay. It assumes when you look at this diagram, you immediately see this is a wavefront coming, hitting a slab. But here the refractive index being one value, no, it changes. So this part of the wavefront will move at a different speed than this part of the wavefront. And so when they come out, this thing is actually come out in a different direction, actually come out this way. And the question is which way it's coming out. That's called deflection. It will be deflected up by this angle, it will deflect up by this angle, it will not reflect it. If this was only one refractive index, you know it's going to go straight through. Because this refractive index has a gradient here, it's going to get deflected. And the deflection depends on this and not, basically if this is the answer, then this D has to be answer also, because if this is the only one, this one you can factor it into -1 and into plus n1. So if you find B is the answer, D is automatically the answer. I have no idea why they put the D there, but anyway, that's one of the things that they gave as answer. Okay, how we do it. So I already identified the principle here that the wave front is coming, and so over here it enters the slab. So let's look at a point A and point B. So over here refractive index is n1. So over here the speed of the wavefront is, let's call it v1 is c over n1. And over here the wavefront is v2 is c over n2. So v1, I already know v1 is going to be greater than v2. So this part of the wavefront will go over here at time t1, but time t1 this only have come up to here. Okay, outside is again is n, so the speed v outside of is just as n equals to 1. So c over 1 is just c. Now this thing comes out, so this end of the wavefront is still going like this, and by the time this goes over here, this time t2, this is time t2 here. So the wavefront looks, this wavefront we used to look like this, now looks like this. So it's going to travel in that direction. So we're supposed to find this angle theta deflection. So if this 90 degrees, and so if you find phi, so theta deflection plus pi over 2 plus phi is pi. So phi is pi over 2, theta d is phi over 2 minus phi. So this phi will be this, from these two distances I could find that, right? So between here and here it has traveled at speed c and taken time t2 minus t1, right? So if I can figure out t1 and t2, I'll be done. So what's the t1? T1 is, this is a distance d it has to go, but it went at a speed c over n1. So it's n1 d over c. T2 is when this guy arrived, the distance. T2 is d over c over n2. So this is n2 d over c. So so let's call this is delta x. So so delta x is c will cancel bottom c, so c times n2 minus n1 d over c. So this is n2 minus n1 d. So far so good, right? So I got this delta x and h. So you can say tangent and answers are given in tangent. So tangent of theta d, if tangent of pi over 2 minus phi, that's a cotangent of phi. Cotangent will be this over that. This will be delta x over h, and that just turns out to be n2 minus n1 d over h. So if I look at the answers, given, is the B, and it depends on the difference and not on individual. This guy doesn't have the individual formula. So answer will be just B and D. Yes, this is a pretty interesting problem. Of course, if you wanted to do this some other way, like iconal equation, more advanced method, you could do that also, but there's no reason to do a more complicated way. This just following the top of the wavefront and the bottom of the wavefront turns out to be sufficient to solve it. So for those guys who want to work out in more general way, what would I do? It will solve iconal equation for ray tracing. You can Google it and study on your own from more advanced books. Okay. All right, so take care for this part. The next problem I'm going to do in the next video is this question 6, which is also an interesting problem. So unlike the problem 4, which I didn't like very much, but question 6 is another good problem. Okay, so I'll see you in the next video. Bye.